if you've run tests inside of a Docker container, if you set up an on-commit action, if you've run Docker machine, and I guess I'm good there, because I run out of standees. All right, consume CI as a service, provide CI as a service. Okay, now this last one is for anybody. Even if you sat down earlier, you can jump up again now if you want to. Are you ready? Anyone? Yeah. No. I was really excited for a moment. Okay. So quick reality check. I am not an expert. I am not an authority. I am just a goofball. I'm some guy who's had lots and lots of mistakes and thought maybe sharing them would be a good idea. This is probably just a bad idea. So if you see something and you're like, whoa, that's wrong, tell me, we'll fix it. And maybe if I ever do this again, I won't tell people the wrong thing. That said, this is a talk about what not to do. So you're going to see me do things wrong on purpose sometimes. So give me a second to see whether or not I show people the right way before you jump all over it. But then definitely jump all over it. All right, so we need a goal. Our goal is continuous delivery. Because, you know, awesome, holy grail, goodness. Wait, what does it even mean? This is an interactive talk. Question marks mean I'm going to stop talking, or at least goad you into saying something. So seriously, what does continuous delivery mean? I don't even care if it's a bad answer. Somebody give me something.
It's the same as coding in prod, but people don't admit it.
Yes, the same as coding in production, but people don't admit it. I love that answer. Anybody want anything else? What do you got?
Making the test environment look a lot like the production environment.
Making test look a lot like the production environment. Yep. Anybody got anything else?
Making development look like production.
Making development look like production. Dig it. So in order to give a silly talk like this, I decided I needed to have a good definition for what this meant myself, and so I went looking, and this is the best one I found. Continuous delivery is the practice of releasing every good build to the users. And I saw that, and I'm like, oh yeah, I like that. That's a great idea. Let's do that. And so I'm like, all right, so what's the easiest way to click quickest, fastest MVP toward that thing? You have got an idea, you code it up, and you get it out there. That's it, right? You don't need anything else. There's like minimal, that's it. I'm like, I don't need continuous delivery tools for that. I can do that right now. I have an idea. I SSH out. I change it, I restart, I'm done. That's why I loved your answer. All right. So, what do we actually need? Oops, I cheated and I gave you guys some answers. So much space bar. All right, these are the things I think we actually need. And had you given me answers, I think they probably would have fallen into one of these three categories. So I tried to write up a new one. I'm like, okay, what would it actually look like? And I decided that it's something like this. This is what my actual MVP would look like. If I were going to tell somebody, hey, I gave you some continuous delivery, it would have to look like this. Or, well, at a minimum, it would have to look like that for me to feel comfortable. Yours would probably look very different. You would immediately go, well, I don't really think you need that right away. And you might say, whoa, you didn't give me this, and I definitely need that right away. But this was mine. And so this was my goal when I started down this path, just so that we know. So this is the star of our show. It's probably why you're all here. And this is what it means to me. So in order to understand Docker, there are, I believe, 3 different things that you need to understand properly and the relationships between them. So they are Docker files, images, and containers. So in order to move further, you got to understand this file right here. A Docker file is just a text file. The command you run in order to turn it into an image is docker build. The command you run to turn your image into a container is docker run. And then if you want to, you can turn that container back into an image with docker commit. If you can understand this image in front of you, you're good to go. If you can't, you're going to have a very confusing day when you start playing with Docker. That said, I failed to understand this entirely the first time I went through, and I had a confusing day. So this is how we start everything, right? We start with hello world. First we run it to make sure it works. Yay, I ran hello world. Now we do it inside Docker. Yay, I'm a Docker expert. All right, let's break it up into pieces, because it was too simple before. Let's complicate it. Here's our command. Here's the name of our image. Here's the thing we want to do, and it's done. But that's just one image. There are loads of images. So let's look at a few of them. Here's some more images. All names you almost certainly recognize. And we can pull them. I think I pulled this one earlier, so it only takes a moment because it's already there, and it says, hey, cached. But you don't need to pull them. If you try and use an image and you don't have it, it will pull it for you. So let's make our echo command happen in each of those different images. Wow, that is incredibly boring. They all look the same. Do not want. So let's make them more interesting. Each of those images has a different thing when you look inside Etsy issue. And now I feel like I'm actually running Docker because I'm getting different results each time. All right. So this was supposed to be the commented command up here, curl ifconfig.me, which returns a tiny little string that is your IP address. Unfortunately, the network here is not so great, so instead, we're going to look at the cookies portion of the help on curl, because that doesn't require any calls to the network. Boom. Unless you guys want to sit here for the 10 minutes it takes for ifconfig to respond, it's not good. So we try it again inside of a container. Boom. Anybody? Bueller?
You don't have curl installed.
Correct. I do not have curl installed. I've encountered my first dependency failure. So I need curl. Wait, this is an Ubuntu box, and I know how to use apt-get, and I know how to run things inside my container, so I'm just going to do it. I'm going to install curl inside my container. And that takes a little while, because, again, network connection. But eventually it finishes. It doesn't take too long. There, all done. Now I have curl, and we can run it again. Boom. Same error. Anyway, what you got?
Your change wasn't persistent.
Yes, containers don't continue to exist. Once you run them, the next time you turn an image into a container, it's a brand new container. The old one's gone. Yes. So we modified our container and then proceeded to immediately use a new one that didn't have the thing we had just installed. And this is because containers are not images. If you want persistence, you have to modify your image, not your container. So there are two different ways to get a new image. You can either Docker commit, or you can build it from a Docker file. You should know this if you remember that graph earlier. So we're going to look at both of them. First, we're going to work on a commit. We're going to do it again inside our container, but we already did, so it's pretty easy. Moving too fast. If you don't use -a, you only get the containers that are running. You have to use -a if you want all the containers. And now there are lots of them, because I haven't deleted them in a while. Containers don't actually go away when you stop them. Unless you add a flag that ~rm, containers will just hang out on your hard drive, taking up space until eventually your computer falls over. So either add a ~rm, or remember, hey, that container that stopped running, it's still there. Named our container. So we can look at just the one that's interesting to us now, since there was way too many before. Oh, okay. And we get back this ugly ID thing that we don't care about because we named it, so we can just use the name. Finish up, clean up all those ugly containers. I have this alias to a command called docker nuke, and I created it so that my coworkers would never have an opportunity to complain to me that they ran docker nuke and something happened. So now we have this new image that we created by committing our container back into an image. And then we have the old image, and we can compare them. And we find that curl takes up about 11 meg. So now we've got this new container that we can create by running our new image that has it installed, and sure enough, we get our cookies. We have our first success. So We'll skip that because there isn't any noise this time. So anybody have any questions on Docker commit before we roll forward with Docker files? I'm moving pretty fast because I know I'm not going to get to the end no matter how fast I go. All right. Docker files are just lists of instructions, things that you would generally type into bash in order to alter the state of your machine. Instead, you type them into a file, and then you run that file, and that's how you get an image. So we create a Docker file. We got a Docker file. We get an image from it by building it. And we only take the last 5 lines because the output is going to be huge. Building a file takes a while. Docker uses a layered approach. Each of those lines inside of our Docker file becomes a layer in the final image. This has the benefit that if you change any line, all of the previous lines are still there and cached, and you never have to run them a second time. The downside is all of the lines following the line you changed now need to be run again. This means you should always optimize the size of your Docker files by making as few lines as possible if those items are created, and you should also optimize by ordering them such that the Docker file lines that change often are at the bottom so that you have to rebuild as little of your image as possible each time you rebuild it. This one failed again. Anybody know why? This one's tough, but the error will tell you if you like Unix. Nope, that's not actually it. Say again? Yes, I do. Ubuntu has a dependency that says my local knowledge of what it is I should be asking for hasn't been updated. And my image hasn't changed, and therefore I need to update it. So let's fix the Docker file so that that happens. Again, build, build, build. This time you do have to run it all again because it's the very first line in your Docker file, so the whole thing has to go over again. It'll finish by the time we get on to the next one. It'll take about 35 seconds, roughly, on this network. At least it did earlier this afternoon. It'll take more now because I'm in front of all of you.
So when you type run, do you feel like you're back in Commodore 64 land?
There are other commands in addition to none. There's add, and the very first command in every Docker file is the from command. It's, hey, what previous image should I be using? And some of those you get for free, like Ubuntu, and others you can make yourself. Like that image, when we named it, could become the from for my next Docker file. And in this fashion, I can load them. I don't get to call in multiple froms. I can only get one from per Docker file, so it's a straight line down. But it could tree out if I have several that all want to use the same base. All right. So it took a little longer, but it finished. So now we have our shiny new image built from the Docker file with the updated dependencies. And we can run it again, and bing, we get our cookies. So here are all the commands we just learned really quickly as we blow through them. You build an image from a Docker file. You commit an image from a container. And you Docker run a container from an image. You can list the images. You can pull images. You can get lists of containers. If you remember the -A, you get all of them. If you don't, you just get the running ones. You can stop them. You can delete them. And if you don't delete them, you can fill your hard drive up with them. And it will fall over. So anything else on basic Docker before we roll forward some more? Yeah?
Yeah, when you committed, are you updating the existing or creating a new?
Committing takes a container and turns it into an image. The container continues to exist, but you get an image out of the result. And from there, you can spawn additional containers based on the current state of that container when you ran the commit.
Is it a new image?
It is. Yep, the old image is still there. Hopefully you name them differently. In my case, I'm not sure I did. All right, so this is going to be a very short section because the command we use to set up the host is called Docker machine, and it's actually much slower than I'm willing to do in a presentation, so all of these are just going to be comments. These are the commands that I used in order to set this up. So you can create a new machine with Docker machine create. tell it what kind of environment. By default, this is a Mac running VirtualBox because I don't have a Linux kernel. And so I need to run VirtualBox in order to have access to a Linux kernel in order for Docker to work. It doesn't have to be local on VirtualBox. It can be an EC2 instance. It can be loads and loads of other fine options. I happen to list the EC2 version because it's what my company uses. It takes a lot more arguments to set up an EC2 instance. So once I have this instance of the Linux kernel somewhere, I have a Docker daemon running. I can point my client to it, and I do that with this eval command here. Docker machine has a command called env, and I give it the name of my environment, which in this case is fumbling forward Docker don'ts. And then that whole thing gets evaluated. That populates the environment variables that tell my Docker client which Docker daemon it needs to talk to. All right, enough with the silly, boring host Docker machine stuff. On to the app. We're going to clear things out first, so you know I'm not cheating. Really quick and dirty Flask app. If you know Flask, you can read it. If you don't, you can read it later. Requirements, because we need to have Flask. And our new Docker file for our new application. Create a directory, pull in that Flask app we just defined, add the requirements file, install the requirements file, and expect people to be hitting you on port 80. That all goes into our Docker file. Now that we have a Docker file, we can create an image from it. Again, we're just tailing the last few lines because this is going to have a lot of output and the slide wouldn't be able to handle it. We're going to name the image. And I hand Docker Compose an argument -f that says, this is the path where you should look for your Docker file. And in this case, I give it the explicit path all the way to the Docker file. Good. Now we have an image. So we can turn that image into a container, and we can run our application. And now, hopefully, we should be able to go over here, and we have Shazam. I can't tell you how relieved I am. But it's boring. It's just one.
So you changed the
Yeah.
original web.py file, and it wouldn't matter because Docker copied the guts of that file.
Correct. Yep. Oh, yes. The question was if I changed the original web.py, the changes would not be reflected because Docker, when I built the image, pulled in that file and it became part of the image. And thus all containers created from that image will not represent my change. Yeah.
We use NFS
Yep.
to like map back to like a local factory level.
Mm-hmm. In addition to pulling things in from your context at build time, you can mount volumes when you move from an image into a container, which is to say when you run an image and create a container, you can mount volumes, and this is what we do for development so that we can see these responses right away without having to rebuild an image every time. But for testing and for production purposes, we don't mount anything. We take the entire repository and add it to an image and then hand that image over as a source container. So if you want more containers, Docker Compose, previously known as Docker Fig. Docker Compose uses a YAML file to coordinate these containers. So we need a YAML file. We'll create one. Pretty easy, by the way. It's only going to have one container. There's only one line here. And then it says, which image do you want me to use? And expose a port and expose it to 80 on my local machine. And then run this command. So start our app up again, but this time we start up using Docker Compose. We can look over here. That's still running, so this is not going to be a very exciting test. Look, still runs. But in order for it to be more interesting, shut the previous one down. This is why. We want to see it down, and then we do it up. Yay! So before, we could use Docker PS and Docker PS-A to look at what containers were running. You can look at containers that are running specific to just that container or just that compose file with Docker Compose PS. Now, even though I might have other containers that exist, the only ones it's going to show me are the ones associated with that compose file. So the philosophy within the Docker community is one process per container. And to that end, when we add things like Redis, we add them in their own containers. So in order to add yet Redis, we're going to update these 3 files, and we're going to do it pretty quickly. After we add all those files, we have to rebuild the image again, and then reload the application again by spawning another container from the new image. Everybody catch this? Now that we have a new container, we want them to be able to chat with each other. And we do that by saying, hey, web, you have a link to this other container called Redis. It does 3 different things. One of them is it adds an entry in the host file called Redis that points to the IP address that Redis receives when it receives one. 2, it takes every environment variable setting that Redis has, prepends a capitalized Redis prefix underscore in front of that environment variable, and hands all of those environment variables to web. So every environment variable that Redis had, web now has prefixed with Redis underscore. And the 3rd thing it does is it makes all of the ports that Redis exposes available as environment variable values within web. So in this case, Redis exposes, anybody know what port? Redis exposes a port, and it uses a protocol to do that, and it has a particular IP address that it exposes it on. All of those pieces of data become available as values inside environment variables of a web. And thus, I, as a developer, never have to care about any of those IP addresses, and they're entirely ephemeral. I can move them around, and Link maintains them for me. So change our Flask app to actually make use of the new Redis resource that it has. And notice the host name is just Redis because it's added to our host file now. And we don't have to name anything in particular. We don't have to know its IP. It's just there because that's what we decided to call the container. And had we wished to name it something else, over here, we could have said link-redis myredis. And then over here, this just becomes myredis. And now the host file doesn't read Redis anymore, it reads myredis, and thus we can pull in multiple services from the same container if we wish under the same link. Let's hope I didn't break anything by making that change. Actually, let's not hope, let's just undo. Add Flask. And now that we have a new Docker file, we need to get a new image from it. It takes a moment to build, as we've worked out. Let's see what we can move forward. Yay! Thank you, caching. Moment of truth. Ah! Because Docker Compose, yep. The question was, why did I just Docker build instead of simply using Docker Compose, which will also build? And it's an awesome question, and the answer is because Docker Compose will only build if there isn't something there already. Yeah. So,
I don't think you executed your the YAML cell when you read it.
how far back was that?
One before the YAML right there.
Oh.
See, it's at 38.
Thanks. Correct. Docker Compose will look and see if there is already an image that has the name that it would have given to something had it built it for you. And if there is such an image, it won't rebuild it for you, even if it has changed. At least that has been my experience. I am open to someone correcting me, but it has bit me enough times that I'm comfortable that that is the case. And Redis is counting for us. So that's a lot of work when you're adding a new service. But we shouldn't need to do all that work when we're just making things that aren't dependency changes. When we're just changing code, we shouldn't have to jump through all those hoops. So let's change some code and prove that. So see how long this takes? That touch tells Docker, hey, this file's changed. I need to rebuild the whole thing. Because Docker is clever enough to create hashes based on the state of the file. And part of my Docker file was to add web.py to the image. I touched web.py and then ran it again. It said, oh, I need to re-execute all of the commands from that add down, which is why there was a delay.
If you reran that same command right now, it would go much faster the second time.
Yep. But it won't because I ran the touch again. I think it's, yep, shift, no, what is it? Control Shift M? Nope. Control M. I can't remember. There's a command that lets me split these, but you're right, commenting is much faster. Boom. So here's our old order. Create the directory, add web.py to it, create your requirements file, and then install the requirements. So because I changed web.py, I had to reinstall all the requirements again, which means I have totally put these in the wrong order. We can fix that. Here's a new Docker file. Requirements get installed first because they don't change nearly as often as the code does. Same command as before. Took about 9 seconds last time. It's going to take just as long this time. But now when we run it again, boom. And I didn't have to comment it out. But what if we want to change it and we just don't want to have to rebuild the image at all? Well, one option is the mounting. We're going to start by decoupling the web.py from the image. We're just going to take that out entirely. And that means yanking it out of the Docker file and putting it and placing it in its own Docker file. Because, well, as much fun as it is to mount things, there's eventually going to be a time when you can't mount them anymore. I like to call it test. Some people call it production.
No test like production.
Yeah. There is indeed no test like production. Users as testers. So over here, we're still running. Over here, we changed it. And it does because I left an image in there. So this is exactly what we touched on earlier, out of order. It will reuse the old one if it exists. It is also why Haya showed up instead of hello when we were asking why it didn't change. It did. I didn't remove the old one. And so from the previous test earlier this afternoon, the change that I was about to make had already been made. It'll only build if it has to. Docker Compose won't build unless you tell it to. It'll build if it has to, but it won't build it unless you tell it to. So in that Docker file, when I point it to a directory, it'll build a Docker file that's there, in the YAML file for Docker Compose. It'll build a Docker file if it finds one in that directory, but it won't build it again after that. It says, I built it once, I'm happy. If you wanted to build it again, you need to explicitly tell Docker Compose to do that. Or be very confused when none of your code changes are represented in your new image because you didn't get a new image. Things we said earlier. This one bit me and I have to share. So volumes are how you share directory type structures between containers. In addition to the link that we showed you earlier, there's also a volumes from. And volumes are also how you mount hosts, or how you do host level mounting. But by default, volumes do not disappear when the container disappears, which is to say if I remove a container, the volume won't go with it. And I didn't work this out until my hard drive fell over again. And this time I'm like, but there are no containers. No, there are volumes, and they're hidden away somewhere, and I had to install another application to go and find them, and it was delightful. Yeah, once more. They can be stored on a host level volume. The question was, where do persistent data structures live? If the containers themselves are ephemeral, where is that data actually being stored? And to my mind, it is still a reasonably open question. The strategy that we are taking presently is to not run them in Docker containers until it is a more resolved issue. There are ways to do it that do involve putting them in Docker containers, and I believe the suggested one is you run them as host-mounted volumes, or you run them as volumes and then simply don't remove that container's volume until you're sure you're done with it. Just because a container hasn't mounted its volume to the host doesn't mean that it's not on the host. It is. It absolutely is on the host. It's just not in a place where you're going to easily go and find it again unless you are that container, or unless you know more than I do, which is probably loads and loads of folks. Yeah.
Just to summarize, I mean, what we do, we either put the data directly on the file system.
I'm actually going to ask you to get a mic, because I'm not going to be able to repeat back everything you just said.
As far as where persistent data goes, at least in our environment, we either drop it straight onto the file system the way that the database running natively would run, or we're using data-only images that mount from volumes, and then we move those images as needed.
Right. The only data-only image that I'm using right now is one from my source repository that I then use volumes from to share with my other containers that need access to the code. But that sounds good. So when I started putting things together and said, hey, we need to deploy this out somewhere other than our local machines, I looked at Amazon Web Services and all of the three-letter acronyms that involves learning. And once I felt I had a handle on all of those, I had a few more things that I needed to learn. And I said, okay, so now that I understand all those things, how does Amazon want me to present this information to them? And the answer is, Amazon doesn't like YAMLs. Amazon wants JSON. And it's essentially a one-to-one relationship between what Amazon wants and what your YAML file already contained. So I looked, and sure enough, someone had already written a YAML to JSON converter for me. And I was stoked. And so I started using it, and everything was going great until I realized that I had another issue. We'll go back to this for a second. My YAML files needed to be able to deal with different scenarios. In some instances, my YAML file needs to mount a volume. In other instances, my YAML file needs to run local databases. if I'm working on development on my machine, I don't want to work on an external database that all of the other developers are using. I want to use the one that's local to my machine. And so when I spin up my YAML file in that instance, I needed to spin up a local copy of Postgres for me. And I also wanted to mount my host volume. But to the best of my ability, I want to use the same YAML file in order to deploy stuff to test. And again, I want to use that same YAML file to deploy stuff to production. And so I said, do I have to use Jinja 2 templating here to get it all to do the different things that I want in different ways? Because otherwise I'm going to write one YAML for dev and one YAML for test and one YAML for prod, and that felt awful. So, okay, I found something called extends, which is built directly into Docker Compose. You can say, this particular image extends this other image in this other YAML file. Or so when you spawn a container, don't use an image or a build directory that you find here. Use whatever it points to in that container. And you can do this as far down the line as you want. And by doing that, I could say, this is the canonical image for this particular service. And this is the canonical directory for this particular service. And know that it was never going to go out of sync because it only existed in one place. And suddenly my YAML files got dry again. And I was thrilled. And you remember that tool that converted my YAML to JSON? It has no idea what extends is. And I quickly backpedaled and said, okay, so my options are to extend this tool so that it understands extends, or to seriously re-examine why I'm pushing these all out to EC2 using the Elastic Container Service, and is that really the MVP? And I said, no, it's not. I can use Docker Machine to spin up an EC2 instance, and I know it's going to have Docker on it, and then I can use Docker Compose to manage those instances without ever having to log onto them personally, without ever having to SSH to them at all. And I can do all of it from my local laptop, and so I do. When I create a Docker machine using Docker Machine Create, and I tell it that it's an EC2 instance, it automatically installs certs on my local machine, and that was fun. Yeah, it installs certs on my local machine and the same certs on the EC2 instance, and now I can run Docker Compose commands from my local machine without ever installing Docker Compose on the remote machine. And this simplified my process tremendously. And it also pushed the entire EC2 JSON conversation out for a little while. And about a month after I made that choice, DockerCon happened, and Amazon announced that they were going to be supporting Docker Compose directly, and I said, yay, I made the right choice. All right, next up was CircleCI. This is, actually, let's not get into CircleCI because I'm told that I am out of time. Let us just go ahead and questions if anybody has any. If they don't, I will totally get into CircleCI.
I have 10 minutes for questions, so please raise your hand if you have a question.
So yesterday, Eric had his talk where he showed that
Okay, thanks.
Eric has that gigantic Postgres database with all of his images in it.
Mm-hmm.
Could that run inside of a Docker process, and then he could just give us that image? Is that crazy talk?
We were talking about that on the way home from dinner last night. I honestly have no idea what the size limit that Docker Hub imposes on their registry is. I'm certain that they impose one because they'd be mad not to. But yes. I think we absolutely should. Yeah, we'll get on Eric's image and push it up and we'll see what happens. But yeah, I imagine that whatever their limit is, it's below 4 terabytes. And if it's not, it will be as soon as we start. But yeah, I had the exact same thought. Anybody else?
Other questions? No?
So CircleCI, I was introduced to it in PyTennessee. Multiple folks were talking about it, and I said, hey, that sounds really neat. And then I went and I dug into it, and I'm like, yeah, that doesn't sound like I have a good use case for that. And then eventually, a couple months later, I circled back around and said, nope, I found my use case. If you haven't used CircleCI, it's delightful. It has a beautiful interface, and it executes a whole bunch of simple commands for you, which is to say, it says, give me your access to your GitHub, and I will execute whatever commands you tell me to whenever anyone commits to the branch that you told me to watch, or to any of the collection of branches that you told me to watch. And it groups those different things that it will do into machine dependencies, test, and deployment. don't need to worry too much about machine and dependencies as different. They're roughly the same thing, and I have that. And I know this because I asked them what the difference between them was, and they said there really isn't any. But the moral of the machine and dependencies are, Circle essentially is going to hand you something close to a virtual machine and say, here's your environment for running your tests. And that virtual machine is already going to have all of your code on it because they're watching Git. And then it's going to execute whatever it thinks it's supposed to, or you can tell it explicitly by defining a circle.yaml file, an example of which is what I threw up there. I loved this. I thought it was fantastic. And then I realized that that random machine that they hand me is not going to be the same one that they hand me next time, or the same one that they hand me the time after that, which means all of those images that I've been building, I no longer have access to the next time I do a commit, which means that they either need to be all pulled down again, or I need to build all of them again, and both of those are time-consuming processes. So I fought with it for a little while, and then I got a hold of the CircleCI folks and said, how do I fix this issue? And they said, we don't really have a solution to that. What we have is a kludge, and the kludge is take your images, tar them up, and save them to a cache. And we will hold on to that cache for you, and the next time we give you another machine based on that branch, we'll give you back the same images, the same tar files that you cached. And so I tried that, and I found that tarring them up, and then saving them, and then untarring them, and then waiting for them to hand me back that giant cache was, if not more, roughly equivalent to the amount of time it would have taken me to build them or pull them down in the first place. So it was delightful. I love CircleCI's interface, and I'm really looking forward to when they do have a solution to that, but it is a really hard problem, which is why I don't think anybody else has a solid solution to it right now either. At least if they do, I want to hear it now. Tell me. This is the simple bash script that I used in order to do that. Go and see what images have been created as a result of this test run, and if any of them aren't already in the cache, put them there. Similarly, script to do exactly the same thing to get them out. And that's all I got.
Any questions? We do have a few more minutes for questions. Just a simple question. Do you get the slides up anywhere?
I do not yet have the slides up anywhere, but I will put them up on that GitHub page that I showed you earlier.
Could you show that again?
Sure.
So I was just wondering, with Docker, how close did you get to your continuous delivery definition at the beginning of the presentation? Is it all you hoped it would be?
That's an awesome question. The reason I agreed to give this talk was because I had gotten tasked with creating a continuous delivery system in Docker. And I said, great, I should have something ready by the time that this rolls around. I'll be able to show it to people. And partway through, they said, you're not doing that anymore. You're doing this other thing now. I said, okay, I'll go do that. So not as far as I would like, but much farther than I had expected is the best answer that I can give you. Oh, and on the topic of my employer, I love them to death. So if anybody wants to come and work for Aver, we're a local Python shop in Columbus, and we are in the second rounds of funding. First round went great. Second round looks like it's going to go well as well. Come join us. Deal with me. Learn Python, or get to use Python you already know.
All right. That's it. Thank you so much.
Oh, GitHub. Sorry, guys. You don't have to clap again. There you go. Cool. Thanks.